The next example is not an example of inner product. The first two were examples of inner products. This is an example of a norm, and this is the familiar example of a norm, and that is the magnitude of a vector. This is the one that's very nice for us to visualize. The magnitude of a vector is the size or the length of that vector, and this is a distance formula or a Euclidean, sometimes called the Euclidean norm. In R2, you can see that a vector v, this hypotenuse is v, a vector v can be broken down into what we call two components, a v1, or like the x component, and a v2, like a y component. And there's a theorem called the Pythagorean theorem that says that the size of v squared, or like a c squared, is a squared plus b squared. And so then we get this formula that the magnitude of v is equal to the square root of the sum of the squares of all the components. So if we had 8 dimensions, we'd have 8 components. And that's a lot harder to draw on my whiteboard. But if we have 2 dimensions, we have 2 components. So if we chop that off, that's exactly the Pythagorean theorem. There's a certain reason that this formula works, and that's because we are assuming this, which is pretty darn safe. But then we'll see that as we move into some very interesting applications, we don't always have this right angle. And that's why we abstract the concept of norm. We are used to having the right angle, and so this gives us our intuition. But then when we see some other concepts of size, where we don't necessarily have the right angle there, we won't have these formulas, but we'll still have all the properties of norm for the concept of size.